moles of oxygen, and it's giving us a balanced equation. So we're going, okay, I've got, and I would really suggest just writing out every time you do one of these questions, the equation. I'm going to do this in pen because that pencil's kind of broken. So write out the actual equation, even if it's already given to you. Okay, and then underneath, write what you've got, what you need. So I've got 1 mole of O2. I want to know how many moles of aluminum. Okay, so for this one, I'm just using my ratio with coefficients. So 1 mole of O2. And then if I use my ratio, I know that there's 4 aluminums per 3 oxygens. Oh, yeah. So I should end up with, what was it, 1.7 or something? Uh, 4 divided by 3. Oh, 1.3. Okay, thank you. Great, so 1.3 moles of aluminum. Okay, here's the thing. A lot of people were, this kind of came up in the next question. What we're looking at when we're looking at the ratio is just the coefficients. So the ratio is based only on coefficients. So the 4 and the 3, this 2 has nothing to do with it. What this is saying is I've got 4 aluminum molecules and I've got 3 O2 molecules. So 1 mole of O2 molecules is 6.022 times 10 to the 23 of these together. So this little subscript 2 just tells you how many oxygens are in that molecule. Do not worry about that at all for your ratio. It's only the coefficients that you're using for your ratio. Does that make sense? Okay, second question. So whenever we're doing these questions, these stoichiometry questions, you always need a balanced equation. You're always going to need a balanced equation. So if you don't have one to start off with, you're going to need to write one. So it's asking me how many grams of something. I'm just going to ignore that for a second and go straight to writing an equation. Solid iodine are produced. So I know solid iodine is one of my products. It's a decomposition reaction. Hydrogen iodide gas is my reactant. So HI decomposition, that's breaking down into 2 smaller pieces, I plus H. These guys are both diatomic. They need to have little 2's. What does that mean for my coefficients? Yep, there's 2 of those. Okay, so my ratio here, I have my ratios here. I have 2 HI molecules per 1 I2 molecule. 2 HI molecules per 1 H2 molecule. 1 I2 per O2. So your ratios, this was the one that people were doing like, oh, I've got a 1-to-1 ratio because of this 2. Not true. You've got a 1-to-2 ratio. So it's the coefficients that are giving you your ratio. So the coefficients give you your ratio, not the subscripts. Does it make sense why that's true? All right. Okay, no? Oh, yeah. Okay. So then I'm going to write underneath my balanced equations how many grams of this are produced. Oh, whoops. Sorry. How many grams of this are produced by the decomposition of 42.6 liters? Okay, grams of iodine, want to know? I've got 46.2 liters. So I'm going to have to go through a series of unit conversions here. First thing is 42.6 liters of HI. I would really recommend writing in the thing that you have. So don't just write down 42.6 liters, write down 42.6 liters of hydrogen iodide. Or else it's going to be, it's easier to follow your work if that happens. Okay, so that's multiplied by, I've got 22.4 liters, 1 mole of HI, right? Okay, so now I'm into moles of HI, which is good. And then from moles of HI, I'm going to go to moles of iodine. So I've got a 2-to-1 ratio, 2 moles, 1 mole, 1 mole of iodide per every 2 moles of HI. Okay, so that's canceling out my hydrogen iodide, and I'm left with just my iodide, which is what I want. But I want it in grams. So now I have to do one more thing where I have to use the molar mass. Can anybody tell me what the molar mass is? 1.9? Thank you, 126.9. So 126.9 grams per every 1 mole of I2. Okay, so if I do that math here, I've got 42.6 divided by 22.4 divided by 2 times 126.9. Okay, if you got 120.67 grams of I2, that's the right answer. Quick question though, is that the right number of significant figures? How many sig figs should I have here, you guys? 3? So I've got 42.6 liters, that's 3 sig figs. What's the other piece of information? No, yeah, that's it. So yeah, 3. So it should be 121 grams with the right sig figs. Cool. Alrighty. Does that question make sense? Did everybody get to that answer eventually? You had double that? Okay, do you have the same numbers written down like this? No? Did I do something wrong? Did you guys add another thing, miss another thing? 233.4. Okay, molar mass. Iodine's molar mass. Oh, 126.9. You guys, yeah, sorry. Wrong molar mass. So 126.9 is the molar mass of 1 iodine. So we're looking for the molar mass of I2, which is 2 times 126.9. Thank you. So it should be 253.8 grams per mole. So yeah, up here, that's not 126.9, that's 253.8. Okay, does everybody get why that is? Why that's 253.8, not 126.9? This molecule has got 2 iodines on it, so our molar mass is double the mass of 1 iodine. So then, sorry about this, we'll just get rid of that. It should be 42.6 divided by 22.4 divided by 2 times 253.8. So we should actually have 241 grams of I2. Okay. Any questions about this one? Okay, I'll go on to example 3 then. If nobody has questions. Okay, this question. So now we are given liters and we're given grams and we're asking for liters. First step, always, we need a balanced equation. So we are looking at O2 gas, and we're looking at hydrogen gas. This is a synthesis reaction, and we're going to get H2O. So in order to balance this, I'm going to throw a 2 there and a 2 there. Okay, so we want to know liters. We are given grams. So what we're going to need to do is start with our H2 and go 16.2 grams of H2 times, and then the molar mass, which again, this is H2. This molecule is 2 hydrogens bound together, so it's 2.0 grams per mole of H2. Getting rid of my grams, I'm into moles. And then I'm going to go over to oxygen. So my molar ratio is I have 2 moles of H2 for every 1 mole of O2. That gets rid of my hydrogen, moves me into moles of oxygen. And then I need to get my oxygen from moles into liters. So for every 1 mole of oxygen, I occupy 22.4 liters of space at STP. So if we do the math on that, 16.2 divided by 2 divided by 2 times 22.4, we should get 90.72 liters of oxygen. And we should be going to, 2 sig figs, I guess. So 91 liters of O2. Okay, did everybody manage to get 91 liters? Does everybody, if you didn't, do you understand how I got to 91 liters? All right, so yeah, those are the solutions to those 3 example questions. Again, just, I think the really key takeaways here. So keys to stoichiometry. The 2.0 grams per mole. Yeah. So depending on the periodic table you have, sometimes it'll go to more decimal places, but this one is 1.0, so we can multiply. Big keys to stoichiometry are always start with a balanced equation. So that's probably the biggest thing. Just always, always, always take your word problem, whatever it is, make sure it's balanced. Use coefficients as your ratios. And what else? Know your conversion factors. Know your conversions like mass to volume or whatever. Yeah, those are probably the 3 biggest things. Okay, any questions about those ones? Yay, nay? All right,